Tell me you want me. 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 Tell me you want me.
Whoa, what's going on, guys? How's it going? It's Mac here from Cryptstar. Nice to see you guys tonight, or this morning, I guess, for a lot of you guys. So yeah, today we're going to be doing a live stream for the Aleph Zero smart contracts tutorial, how to program smart contracts. Super excited. You guys might not know, but I am not a programmer myself, so this is going to be a very interesting experience. I'm trying to learn Rust. I did buy a little How to Learn Rust book. It's like the generic one with the little crabs in the front. I don't know if you guys know that one, but hopefully I can have some time now that my project at work is mostly finished. I can get some time to study that at night without having to do too much overtime. But yeah, I did manage to update the studio a bit, so the live streaming should be a lot smoother from now on. I tried to update some of the microphones, as well as I got an overhead camera now, so I can start doing some more hands-on tutorials. Today we're just going to start off with a little unboxing of some Azero goodies before this tutorial starts here in 3 minutes. So yeah, let's just go ahead and switch the camera over. Alright, sweet. So yeah, you guys, I did create a website, and I also created a bunch of designs for Azero goodies. So if you're interested, I did reduce the price a lot. I put it up there trying to follow like the best guidelines, and it was like 40% margin, and I'm like, 40% seems a bit high, but that's what everyone does. But I'm like, that seems like, you know, 25 bucks for a mug was just too much. So I lowered it quite significantly. So it's like, I think 10% margin or something. So that way, hopefully nobody does any returns, because it would completely make me go bankrupt. But yeah. Anyways, let's go ahead and open up this awesome mug. I got it in the mail today. It took about 2 weeks. It looks like it's shipped from the UK, I believe. So it's actually not from Japan. Sorry, guys. It's shipped from the UK. We have a supplier out there. So yeah, let's go ahead and open it up and check it out, guys. Super excited for this. I'm gonna be drinking my coffee with this tomorrow. There we go. Oh my god. Okay, well that didn't work at all. I just totally ripped the box. Oh, there we go. Oh, there we go. Nice, nice. Okay, sweet. Oh, this turned out really nice. Oh yeah. Look at this, guys. This is pretty sick. Can you guys see? Oh, here it is. So you guys can see the little Azero logo here. And you can see on the back, I love Azero. Isn't that cute? Yes, very nice, guys. So if you guys want one of these, I do have it on my website. Take a look. The build quality is, yeah, really good. I just want to, you know, get a sample one before I started like trying to promote it at all. It's really hard to get Azero goods. I did, you know, talk to the core team a little bit, but they never sent me any goodies, so I just kind of went out and made my own. Anyways, this is what it looks like, guys. It's pretty sick. Yeah, let's go ahead and switch back the camera here so you guys can see. So I don't know if you can see it here. Put in there you go. I love Azero. Very nice. And then it has the Azero logo on the back as well. And if you guys take a look, we do have some other swag here. So I have Cryptstar Castles swag here, Cryptstar Castles. Oh, I need to fix it so it doesn't like go sideways like that. But yeah, you guys can see all this different swag, a hat. I have some of the hats coming. I want to try those out as well. So if you guys want to wait and see what it looks like, I'll do a video on these before you want to order. But if you guys want some Azero cups, this one's really nice. It's only 10 bucks, so pretty cheap. I'm not sure how much the shipping would be, but yeah, this is a really nice one as well. I like this one just because this is, I think, 15 ounce, and I think this is only 12 ounces. So if you like a little bit more coffee in the morning, and also I think this is a really nice, like, higher quality mug. So if you guys want like a little bit higher quality, this one's just like a regular small mug, sort of generic. But the inside accent color is cool, a red accent. But yeah, it looks like it is time for the class. So let's go ahead and jump over here. And I think if I refresh the page, it should work. If not, I'll have to jump in the Discord and see what's going on. So sales ended. Location online. It said it's here, so how do I log in? This is the question. I think this is the website. I'm pretty sure this is the Aleph Zero website. No, this is Polish Blockchain Association. Okay. Maybe it's here. Let's check out my tickets, guys. Maybe it's here. I'm Bob Miley, by the way, and I ordered like 3 of the same ticket because you could order as many as you wanted, and I wasn't sure if it was working correctly. So yeah, okay, let's click on this. Maybe this will take me to the correct link here. No, still don't see how to do this. It said it was 11 p.m. to 1 a.m. GST. It's now 11:02. I feel stupid right now. I'm feeling very stupid. Hey guys, do you guys know exactly how to enter this? I feel really stupid right now. There's got... How the heck do I join in this? All right, let's go ahead and hop in the chat real quick. Just I'm gonna hop in the chat and see what's going on here. Dun dun dun. All right, this is very awkward. Very awkward. I'm just kidding. I figured something like this would happen because I asked him. And it was like, yeah, it was like he said it was here, but okay. Is this okay? So what's this? Do I have to what?
Rust programming in general, not only ink, but
oh, wait, they're are they doing it?
Hopefully, everyone will get something out of this.
Oh, you can't actually watch it on the website? Oh, I'm so lost right now.
We are going to have this stream posted on our YouTube channel.
Oh, okay. I'll shut up now.
We're gonna have the Q&A session at the end, I think, if we have time. Yeah, but you can ask questions anytime, to be honest, so we can answer them on the go. And mostly once we're gonna see the more programming part, when it's a bit more complicated. So if something's not clear, something needs a bit more of explication, just post a comment, post a question, so we know that something needs to be clarified. Hope you have your coffee. I just grabbed a glass of water. And
actually, disclaimer: the thing I'm gonna drink is not beer. It's like yerba mate lemonade. I used to get this. Like, are you drinking beer now?
Not the time to drink
no,
beer.
No,
we're gonna drink one after the
yes.
webinar.
Okay. So yeah, let's dive right in, I guess. So okay. First slide, we just talked about the introduction. So I wanted to start by talking about smart contracts in general. And this definition here is the one I've taken from Wikipedia. And well, I've included it because the name contract actually may be misleading. So treating smart contracts as actual contracts between two parties may not be actually the most useful intuition. You can kind of think of them as contracts in a way that some people think an API is a contract. So you know the application promises to give you back some data once provided certain input, but like I said, I don't think this is the most useful framing of the whole smart contract idea. I like to think about them as essentially programs that execute on the blockchain, because when you think about the blockchain, it's actually very similar to like, well, a theoretical model of a computer. So it has some processing unit, the runtime, and some storage in form of the actual blocks that get created. So this model is actually way more useful, at least for us devs. So this is just programs that execute on the chain, as simple as that. And of course, you know, once you have the ability to actually write programs on the chain, you can create applications in, well, distributed applications in a number of use cases and a number of areas. So the most, I don't know, popular one probably is DeFi, decentralized finance, but you also have very interesting use cases outside of DeFi. So digital identity with KYC and KYB processes that can be done, especially with the privacy involved. This gets really interesting for like maybe more corporate usage. Supply chain management and provenance tracking is quite an interesting use case. And of course, there's the whole certificates of ownership area with, you know, we all know NFTs, but you know, the profile pictures and collectibles are one thing. You can also track the authenticity of art, track, you know, ownership of real estate, manage software licenses using NFTs, manage tickets to events and whatnot. So there's numerous use cases. And of course, you know, we always encourage everyone to come up with their own use cases because, well, this is still a very young and exciting space. So we encourage everyone to basically think of their own next great dApp. Of course, well, decentralized finance is quite a hot topic, and well, I kind of thought, you know, like including a definition here legitimizes the presentation a bit. So here it goes. But basically, we can write smart contracts to, you know, kind of mimic and improve on what traditional finance, centralized finance is doing, without any banks, without any trusted intermediaries. So everything is trustless, everything is on chain, and this is users talking to smart contracts and smart contracts talking to other smart contracts. And there's a lot of great examples, but for example, decentralized exchanges like Uniswap or Common that we at Azero are building. There's lending protocols like MakerDAO. There's trading markets. There's crowdfunding platform such as AngelBlock. There's payment solutions and many more. Okay, yeah, but this was just to well, kind of show that, okay, there is some actual, you know, value involved, and sometimes the smart contracts handle a lot of tokens, a lot of users' funds. But of course, as always, with great power comes great responsibility, and it's up to us, the programmers, to write the contracts with, you know, a lot of safe design, good programming practices, and to make them resilient against attacks, robust, resilient to simple logical and programming errors. And this is, you know, like half jokingly, I allowed myself to propose this grand theory of hacks, which kind of plays really nice into what I'm gonna say about the type system in Ink and in Rust. But I would stipulate that exploits happen or can happen in the places in your code when you are not 100% sure what's going on, right? So, well, to that end, I would, when writing smart contracts, I would avoid any implicit operations, for example, as well. If your logic allows it, then I would avoid them. It's really cool to have everything written out and everything be quite predictable. I would make sure to validate what's taken from the users and given to the smart contracts. Of course, again, type system helps here, and we're gonna exactly see how it helps both the users of the smart contracts and most importantly, the developers of the smart contracts. I think we should not really avoid, because they are unavoidable, but really be quite careful when mutating the state of the contract. And disclaimer here, I come from a functional programming background. I used to be a big functional programming nerd, so for me the mutating of the state is like this very unsafe and special thing. But again, we're gonna see how Rust and Ink more specifically helps us avoid at least the unwanted mutations of the state. Of course, any loops in your code, any places where the code repeats a number of times are potentially unsafe, especially during recursion, so functions calling other functions, and even more importantly and more dangerously, contracts calling other contracts. And as we're gonna see in just a second on the next slide, I would be very careful about catch-all methods, so like wildcard methods. You may know them from Solidity. It's like the fallback method is quite unsafe, which actually plays really nice into the example. And this is old news. We've all seen this, and this is an extremely simplified version of the DAO hack. I mean, it tries to capture the idea. So this is basically a simple reentrancy attack, but I wanted to talk about this just to show how an extremely simple, let's say not even a mistake, but vulnerability in the code, especially one extremely easy to fix, how it can have very drastic effects and cause a lot of damage. So there used to be, well, the way it looked is there was a DAO contract, which, well, for our purposes, it basically had two methods. You could deposit some funds, and you could withdraw some funds. And the way the transfers in, here we are talking about Solidity. The way the transfers work is they basically, importantly, this is a transfer of the chain's native currency, right? So the contract can receive the native currency, and it has two ways to handle the incoming transfer. One would be the receive method, and the other one would be the fallback method. And the fallback method is quite dangerous because it can include arbitrary logic in its body. So the way that this hack was actually the way it happened was someone deposited a certain amount of ETH. Let's say it was 100. Then they proceeded to withdraw, to ask the contract to withdraw the same amount, or actually might be even less. And the DAO contract basically first checked if this withdrawing account had enough funds. It did. The next line was to transfer the amount to the withdrawing contract, and only then update the balance of the caller in the DAO contract, right? But the problem is the smart contract doesn't consider the transfer transaction to be done until basically it has stopped executing. And this means also when the method on the receiving end has stopped executing. So the way the fallback method in I'm calling the attacker malice here, but the way the fallback method was written, it actually contained another withdraw. And you will notice that because the balance was updated only when the transfer was completed, it entered in an infinite loop of transferring, the fallback method triggering the withdraw method again. The contract was checking the balance, but it still hasn't been updated because it was just this one line executing over and over. And yeah, this is why it's called a reentrancy attack, because the attacker was like re-entering the contract again and again. And the only thing the fallback method needed to have, aside from the withdraw method, was obviously a check whether the DAO contract actually has any funds left. Because if it didn't, then it would abort the transaction and actually abort the whole loop. But yeah, there was a check. So basically, people from the DAO were watching their funds being drained, and they tried to do this thing where they were trying to drain the DAO faster than the attacker. But yeah, it was quite an unfortunate hack. Of course, this has all been fixed since, and the landscape looks a little bit different. But this goes to show that sometimes the wrong order of two lines can cause catastrophic damage, or like a very simple error in your code can have a lot of repercussions. So this is why I would like to tell you about not only writing smart contracts in ink, but actually paying a lot of attention to writing good and solid smart contracts, because it all starts there, right? It starts with writing solid code and the compiler helping you the best way it can, and then testing your code and auditing your code. It's all part of the good programming practices. But ending this lengthy introduction, let's get into it. So first of all, of course, we're gonna be talking about smart contracts in ink, which is a smart contract language working on quite a few chains, not only Aleph Zero, but obviously I'm gonna focus on Aleph Zero. That's where I work. That's what I know. So Aleph Zero is a layer 1 proof of stake blockchain. It's built on top of Substrate, but with our own Aleph BFT consensus plugged into Substrate to give us some good properties and some sorry, I just seen the comment, right? Solid code, not solidity code. Yeah, I like it. It's funny. Yeah, Aleph BFT is basically a pretty good peer-reviewed consensus that allows the chain to basically work really fast with sub-second finality times and actually the block times as well. We're focusing right now a lot on the privacy aspect of things and building out the liminal privacy framework. You can actually see like the developer preview in form of the shielder that you can find in our docs and in our repository. There's going to be links just in a few slides. What's actually quite important for smart contract development and actually can influence the way you think about smart contracts and the way you write them is very low transaction costs. So it's 0.0003 Azero, which it's basically a small fraction of a dollar when you convert it. It's pretty cool because basically you don't have to do some crazy tricks in order to optimize the smart contract cost. You can basically write it as normal code, and of course, if you're very irresponsible with the storage and you start storing, I don't know, videos on chain, then it gets expensive. But if the contract is quite conservative with the storage and written okay, you won't have to worry about the transaction costs, and definitely you won't have to tweak the bytecode to squeeze the last cent out of the smart contract. Yeah, and basically the feature we're going to be talking about today is smart contracts in ink. For those of the audience who don't follow our social media, we have smart contracts on mainnet, and there's a lot of use cases being deployed. We have the ecosystem funding program, so there's a lot of exciting developments. But let's get on to talking about ink itself. This is probably all of the links you will need to start ink development. There's a QR code if you want to scan it, but it basically points you to the alephzero.org website, so maybe not very useful, but I like how it looks. So the alephzero.org website is obviously the main website, and you can go to, I think, all of the links below, like in just a few hops. But some of the important links that for the ease of use. docs.aleph0.org. This is our main documentation, not only for smart contract developers, but also with like general information about the chain, with information about staking, with guides for validators for setting up their nodes. Right now, we also have a very cool security course by Kudelski Security. So yeah, as far as writing secure smart contract goes, it's definitely worth giving a look. So then the next link is the developer portal, which also contains some useful information. If you start developing the contracts, you will definitely need some accounts on the testnet, because, like I said, good practice: test your code on locally first, testnet second, and then audit, and only then, after everything's audited, tested, through and through, then you can think about mainnet. But it's really good to be quite conservative about going to mainnet.
That was one of my first questions. If you have a testnet, if I can.
Oh yeah.
If I write something, where I can test it. That's like.
Yeah. Well, I would actually. We're gonna talk about testing a bit later, but it's actually quite easy to basically run your local instance of the chain. So yeah, like you can run one node or a few nodes and play locally, which basically the workflow is the same as on testnet. Then you can go to the testnet and work from there. So this test A0 dev is like this developer wallet. You will use it to basically have some accounts created and so on. Then for actually interacting with the contracts and deploying contracts, there's this contracts UI. It's quite handy. You can interact with the contracts from command line only. I'm not gonna talk about working with the command line as far as contract deployment goes, and calling smart contracts, but you can find this in our guides. There's a second link, and importantly, the last link is the Polkadot.js API, and this is one of the questions that I get the most often. So it's like, okay, I have the smart contract, cool. Now how do I make my app communicate with the contract? So basically, this is how you can use Polkadot.js API. You can also use basically any Substrate compatible client. There's good implementations in Python Substrate interface. There's subxt in Rust. There's many more. But for frontend, I guess the default would be the Polkadot.js API right now. There's a question: is Kudelski now one and only eligible for A0 audits? No, but this is the firm that we ourselves and our ecosystem funding program are in partnership with. So yeah, our ecosystem funding program projects have the possibility to use audits from Kudelski Security. Well, definitely, this is a very good auditing company, but you're free to choose any good auditing company.
Do your own research always.
Yeah. Okay, so I've talked about the whole landscape. Let's now talk about Ink specifically. So what is Ink? Well, of course, a smart contract language, but like technically, Ink is an EDSL built on top of Rust. That means embedded domain specific language. So this means this is not a standalone language like, say, Solidity. It's a subset of Rust, and with some macros added to help you with the development and do some contract specific stuff. Also, it's worth noting that it actually really is a subset, because EDSL sometimes can get quite different from the host language, but Ink is very, very similar to Rust, but the easy subset. It's actually quite easy to learn. Rust can sometimes get a little tricky with memory management and lifetimes. In Ink, you don't encounter the most advanced features. But given that it's a part of Rust, essentially, it has the same benefits as Rust. So definitely, this is a modern language, and the creators evidently paid attention to the programming language research of the recent years. The type system is really cool. It's really safe, basically as safe as it can be without sacrificing, let's say, developer ergonomics. You definitely can create a more powerful type system that will allow you to prove different properties about your code. But those languages generally tend to be very hard to use. Rust is memory safe, and in quite an interesting way, we're gonna take a look at that. It's memory safe and basically with zero runtime overhead and no garbage collection. This is cool. The tooling is good. You have some plugins, and it's winning the Stack Overflow surveys for the most liked language by developers. Now, interestingly, the chain doesn't actually require you to write your contracts in ink. It just requires you to compile them to WASM. So WASM is this binary format for, well, it's WebAssembly, basically a fast binary format for the web. Ubiquitous, fast, secure, obviously. And the interesting part is that if you actually can take your favorite language and compile it down to WASM and adhere to a certain ABI that the chain will understand, you can actually run it on the chain. These experiments have been done. My colleague has been running F-star code on Aleph Zero, and it actually ran. But it's not easy. The most convenient way is definitely to still use ink. Now, this table may seem a little daunting, but it's just treated as a picture. It's basically, I use it to illustrate that ink and Solidity actually share a lot of ideas, share a lot of concepts, and that means that switching from Solidity and over to ink is not as hard as it might seem. So you will basically be familiar with.
Maybe before we go with differences, maybe you can respond to the question that show up about the opportunity to connect the MetaMask and translate the ETH address to Aleph format.
This is a very, very interesting question, and actually one of our projects is the MetaMask snap for Aleph Zero. So soon, yes, you will be able to connect MetaMask to Aleph Zero and use MetaMask basically as the signer of transactions.
Perfect. So future to come.
Yes, actually, you can. I think the Aleph Zero account tweeted about it just a few hours ago, so we'll be able to find it quite easily. And there's a blog post that describes it in a little more detail, because I'm not directly involved in the project, so I don't want to lie. I like to talk about what I know,
Nice.
but the blog post is there.
Thanks for the question. Thanks for the responses.
Yeah, exactly. What JD posted. So yes, so back to what I was saying, ink and Solidity, you will be familiar with most of the ideas. The type system is a little different. I like ink's type system a little better, but that's a matter of personal preference, obviously. The syntax is a little different, but in general, you will feel right at home. One difference that's quite notable is that in Solidity, all the storage entries are 256-bit fixed size, whereas in ink they can be of variable sizes, which actually has a huge impact on performance. So this is a cool thing. Yeah. So this is basically at a glance what's required to start developing ink smart contracts. You will obviously need some dependencies installed first, some prerequisites. Obviously, you will need Rust, which also will install Cargo. You will need to install the Cargo contract component. Cargo is, if you're not familiar, is basically a package manager and build system and like a general purpose tool for writing/deploying Rust programs. And the Cargo contract extension has some smart contract specific abilities, for example, to deploy smart contracts to the chain. Now, what you do then is you use Cargo contract new to bootstrap a new contract. And if I actually can share it, oh, no, maybe I will share the screen later to just keep the flow of the presentation intact. Then once you actually run Cargo contract new and then the name of your contract, you will be left with some basic boilerplate that compiles and actually contains all the necessary elements of a smart contract. Um, which is actually really important. It will have, most importantly, this lib.rs file, a file with Rust code, which is the main code file of your smart contract, and inside you will have the complete structure of an Ink smart contract. And this is important to keep in mind as we will be going through the next slides, because there's gonna be a lot of different macros and a lot of code structures, but it's important to remember that you never start with just a blank canvas in Ink. So you either use this scaffolding tool and start with a simple flipper contract that you can then add logic to and modify the storage struct and so on, or you start from some boilerplate, like for example inkathon.xyz, if you want to check that out. This is a full stack dApp, but also includes some Ink smart contracts. Or if you, for example, want to do a PSP22 token, or well, ERC20, if you're not familiar with the PSP22, we're going to talk about that in a minute. You can take some existing code and modify it to your needs. So yeah, there's no real need to actually remember every character of what I'm gonna say. This is mostly to give you the overview and equip you with enough knowledge about Ink so that once you see a smart contract, you basically know what to look for and what to focus on. Okay, so once you have your contract, you can obviously oh, there's an error in the slides. I'm sorry about that. You do cargo contract, well, test. The nightly is optional if you want to use some new features of Rust, if they're required by, for example, one of the libraries you used. And then you do cargo contract build, and I would recommend adding -- release. Now, this will give you with 2 artifacts. Now, this is a joke about the off-by-1 error, but most importantly, this will give you the contract bundle that you can upload to the chain. And I'm scared, but I will later do a very small live demo of how this looks, the whole interaction with the chain, so we can walk through this together. Now, yeah, like I said, we're gonna present that later. I have some screenshots, but maybe we'll do a live demo. We'll see. Now, in terms of what we are actually gonna build today, we're gonna build a PSP22 token, which is the substrate version of Substrate Aleph Zero Polkadot version of an ERC20 token, so like a basic fungible token. I'm calling it Petecoin because it's a wordplay and it's my name, and it kind of has a nice ring to it. I've had these questions before. This is not an actual coin you can buy. It's a joke for the presentation.
It's not listed on Binance, so
no,
you can find it.
Believe it or not, I get these questions sometimes when I talk about Bitcoin. Yeah. Okay, so it's this is the standard. This is exactly what it is. It's basically a set of functions or set of messages that your contract needs to be able to respond to in order to be treated as an ERC20 token. PSP22 is basically the same. The return types are slightly different. Now you will notice that basically your contract needs to be able to tell you the total supply of the coin. So like, thank you for the kind words about Bitcoin. The total supply, so all of the tokens circulating, balance of a specific account. We're gonna skip allowance, approve, and transfer from, just because it's basically to allow someone, for example, a DEX, to make transfers on your behalf, and you can approve a certain amount to be transferred by someone. Obviously, there's the transfer method, arguably the most important one, where you get the tokens, the coins, and transfer it to another account. And there's events that the contract needs to emit. We're going to talk about events later. Now, okay, since we know more or less what we are going to be building, let's start with the contract. And obviously there's some boilerplate. And remember what I said, when you bootstrap the new contract with cargo contract, you basically get all of that for free. So no need to do screenshots or anything. But it's useful to actually go almost line by line here just to introduce some concepts from Rust. Now, the lines starting with the hash symbol are not comments. This is not Python. They are macros. Macros, if you're not familiar, is basically code that writes other code. Yeah, so some meta programming. The first one basically tells the compiler not to use the Rust standard library. Inc has its own smaller standard library that is able to compile to WASM as a whole. Then let's actually talk about the mod Bitcoin here. The mod is a Rust module. So a module is, you can think of it as a namespace if you like C++. You can also think about it basically as a collection of things you can put inside, like structs, function definitions, constants. So a module is a collection of stuff. Above the module, if this module actually describes a smart contract, you need to include the inc contract macro. And there's quite a big amount of magic that the inc contract macro does. If you're interested, you can always tell the compiler to extend the macros and see what it actually gives you. But some of the things are like the most, I guess, important to us developers is that it enforces certain invariants. We're gonna talk about them later, but that the contract needs to like hold. And it gives you some useful aliases. So we're gonna later see the balance type, the account type. So yeah, there's quite a lot going behind the scenes here. You can always, of course, view it by expanding macros. It's quite easily Googleable, so I'm not gonna bore you with this here. Now, the line with use inc storage mapping. This is I was gonna say it's an import, but actually in Rust the use is more similar to the use you might know from C++. So like introducing some names into the namespace, or like binding a name to some entity, because it's not like Python imports that can, for example, execute code when imported. This is just plain, like making the name shorter. You can also re-export using use. Then you write pub use, but that's not important for now. Now, okay, yeah. Moving on, probably the most important part of the smart contract is the storage struct. So it's a Rust struct, as visible by using the struct keyword. So a struct, again, quite similar to C++ struct, but actually similar to objects in pretty much any modern language. Importantly, structs are not like, let's say, Java classes, so you cannot inherit after a struct, which is quite important. I'm not a very big fan of inheritance in general. I think it's very overused in programming. However, interestingly, Rust does have a form of subtyping, because inheritance is just one form of subtyping. But it's completely beyond the scope of this presentation. And similar to a class, you can actually attach behavior to a struct, but you do it in a separate block. That's on the next slide. And of course, a struct has fields, and the fields have names, and you can access the fields by name and using a dot. So, like in any self-respecting language. Importantly, similar to the inc contract macro, here you need to include the inc storage macro. Of course, the boilerplate will include that for you. It basically tells the contract to put this specific struct on chain. This will actually be stored on chain. If you declare any other structs, you can, but they cannot be stored on chain. So there can only be one struct marked with the inc storage macro in your smart contract. Now, here, for the purpose of our PSP22 token, we're gonna have two fields. One will be the total supply, which is of type balance, which is one of the primitives given to us. Well, type alias is given to us by the contract macro, but it's actually a unsigned 128-bit integer. Then we have the balances, which think of it as like, the accounts in a bank. The bank basically keeps track of this account has this much money, this account has this much money. This is exactly what we are going to simulate here. So we have a mapping, which is like a hash map, mapping from account ID to balance. Okay. Now, as I said, we can attach behavior, so methods, to our structs. So in that respect, they behave kind of like classes, but without inheritance. We do it using this impl, short form implementation block. So impl, name of your struct, and there you have it. You've attached the implementation. So one method we need to include is the constructor, and a method is a smart contract constructor because it's marked with the inc constructor macro. And actually, the contract macro enforces that you have at least one constructor in your code. You can have as many as you want. How to iterate over mapping. Oh, sorry. To be honest, I have never done this. Never felt the need. I know how to iterate over like map in regular Rust, but I think I can check later and include it in our guides. So sorry for disappointing you.
Maybe Tomasz, you can explain a little more what your what's the reason of the question. Maybe we can give you a other solution to the same problem. But yeah, let's continue. You will see if any clarifications posted. By the way, all this information you can find it on the Aleph Zero documentation site. I checked and it's there, so you can go.
Actually, I checked quickly, and there is no like built-in way to iterate over a mapping. So you may need to do some workarounds, like because the mapping is optimized in a way that yeah, I think mapping is more cost effective, like more storage effective. But yeah, it lacks certain elements of the API. Okay, I think we can move on. This is not the answer to the question I would like to give, but it's the one I have. Right. So inside of the constructor, what we do is, well, the constructor can take arguments, and importantly, these arguments will be like visible to the creator of the contract, because, well, we are the developers of the contract, but later we can give it to someone to instantiate, and they will need to fill these arguments on contract creation, the arguments of the constructor. I'm sorry, I'm trying to keep up with the comments and with the presentation. It's a little tricky for me. Right. So our contract will just take the total supply initially. You can, of course, include some more data here, like metadata and so on. But for this simple example, this is enough. And the first thing we're gonna do is we're gonna create the balances mapping. Now we're gonna use the default method. This is basically a trait you can implement on your structs to give them default implementations. If you're familiar with the concept of a monoid, this is basically like the empty element of a monoid, but it's not necessary to know in order to use it. So basically, sorry. So basically, default value for any number would be 0. A default value for a mapping would be empty mapping. For a list, an empty list. And actually, let me go back a slide here. And you don't always have to write it yourself. You can use the derive default method. And then Inc will try to descend into the fields of the of your struct and use the default instance for each one of them. So this way, for the mapping, we basically get an empty mapping. Then we get the color of the smart contract. And yeah, first of all, we use this magical self-env method that basically gives us the access to the environment in which the contract is executing. And you can get stuff like, for example, the color of the smart contract or the account of the smart contract, because each smart contract actually is an account on the chain. So this is a way to get our color. And in this example, because this is a constructor, so the person calling the constructor is actually the contract owner. So the color here is actually the owner of the contract. And since the contract is being created, and this is the only user of the contract right now, because no one has interacted with it before because it's not yet created, we go ahead and insert into our mapping the pair which assigns the whole total supply to the color. And later, of course, the color can do transfers and so on. By the way, this is how you insert into the mapping. Yeah, answering the comment, yes, in general, you won't be able to use the standard library from Rust with Inc smart contracts. Yeah, so lastly, this method needs to return something. It needs to, the constructor as always returns the instance of the class we're creating. So here we'll use self to, well, write we could have written Bitcoin here instead of self, but this way is, well, a little cleaner, a little more generic. So we basically give the field values here, and yeah, and it should work. And now you're able to actually create the contract. Now, a side note here, because we've already seen some, like weird ampersand signs, and we've created some structures. So I felt like it's a good idea to talk a bit about the memory management in Rust. And of course, in Inc, you won't need to really dive into the specifics and play with the lifetimes and whatnot, but you still will need to know the references and the concepts more or less. So Rust is implementing something, well, it's using something called the ownership model, in which basically it says something like this. Everything we allocate on the heap, so, not like the intermediate stuff you allocate on the stack, but like the real deal data you allocate on the heap. Every piece of data has exactly one owner. And the owner here might be a bit tricky to grasp, because it's not like it's assigned to a specific person. It's more about which scope can access this piece of data. Scope meaning like a part of code, for example, a function or a block inside the loop. And now the way it is structured is, if you're the owner, you can of course access this data. If you're not, you cannot. Now, there's two ways of transferring this ownership, because obviously the data is flowing through different parts of the code. So one would be moving of the data. You might know that from C++, it would be std move. Here it's a little bit simpler, because anytime you pass by value, you're essentially moving data. This is not entirely true, but for this moment it's okay. So you're moving the data. You say, okay, I am no longer an owner of this data. The function I've passed this data to will now be the owner of the data, and you can modify the data inside this function. Another way is borrowing. So again, I keep coming back to the C++ analogies, and I don't even know C++ that well, but borrowing is basically like passing by reference in C++. The difference being Rust keeps track of who borrowed what, when, and so on. So if someone borrows the data, they will be able to do something with it, but they need to give it back, basically. So you will be able to use this data later. And this whole model may seem a little daunting at first, but what it gives us is basically that we can have full memory safety. Everything is checked during compile time, and the runtime overhead is negligible. There's no runtime overhead. So if you compare it to like running a language with a garbage collector, for example, which can sometimes, in the worst case, like stop your whole application and do the actual garbage collection, this is actually pretty cool. And on the other end of the spectrum would be like manual memory management and memory leaks and so on. Right. So, I don't know if the contrast is not so great on this slide, but let's hope you'll find that readable. So this is a very simple example. If you're not interested in the move semantics and borrowing and everything, you may get your coffee now. But I think it's quite interesting. It's the simplest example I could come up with. So let's say we have this struct that has a single field, and we have a function that takes a struct, a foo struct, and it takes it by value, right? There's no ampersands, there's no nothing. What it does is it basically returns the value of this field incremented by 1. Then in our main function, we basically instantiate this struct, create it, then we pass it to this function, and we try to see what happened to the field of this struct. Okay. Well, we get a compilation error, and I actually would like you to take a moment to read this error because it's incredibly helpful when you think about it. Actually, the compiler tells you exactly what's wrong, right? Well, there's a move. The copy part, don't worry about it. You can basically say this struct is very easy to copy, so here's how you copy it, and then instead of ceding the ownership, you can basically copy it to someone. As long as you're sure that the copy won't take a lot of resources, that's fine to do. But for this example, we don't want to implement the copy, and we see that we're moving the value, so we gave away the ownership to the function, to the pass by value function, but we want to use it afterwards. And Rust says, you cannot do that because you no longer own this particular struct. Okay. Now I say, okay, that didn't go as planned. Let's modify our function a bit. Let's call it pass by reference, by the way, and it's gonna only borrow the foo struct, right? And what it's gonna do is it's gonna modify the field in place. It's a field called field. It's like naming your dog, but I thought it looked okay for this example. We do exactly the same thing. The only difference is that we now explicitly say, okay, let's pass this value here by reference, and we try to print it. It makes sense, right? We're no longer giving away the foo struct, we're just borrowing it. And the function is trying to change it. Can we do this? Well, no. We cannot do this because, and again, the compiler is quite helpful. It says, okay, you're trying to mutate the value here, but you didn't tell me it's okay to mutate it. So remember what I was talking about, being extra careful about mutating the state. This is pretty much how the compiler tries to help you here. The compiler says, well, unless you tell me explicitly it's okay to mutate this state, I won't let you mutate it, which actually is cool. I mean, in a larger code base, I think it's quite easy to change something on accident, right? You just forget about it, increment some counter or something like that. So Rust is quite conservative with mutating the state here. And of course, well, there is a way to fix it. We just need to explicitly tell Rust that it's a mutable reference when we declare the function. But then when we are passing it, we need to tell Rust, okay, we are borrowing. Well, we are borrowing here, but in a mutable way. Now, interesting stuff starts to happen when you borrow a value into a function and then want to return it from the function, but that's beyond the scope of this talk, and actually doesn't even happen that often in Ink smart contracts that you need to think about it. But if you want to, you can read about Ink's lifetimes, and there's this whole lifetime polymorphism. It's actually super interesting. But that's for another time. Okay, so after this lengthy sidebar, let's get back to our actual smart contract. So, okay, we already have the storage struct definition and we have the constructor. So it's cool. We can create the smart contract and even initialize some data, but we still have no way of interacting with the smart contract. So in order to be able to actually, ask the smart contract a question or tell it to do something, we need the messages. And messages is basically another name for methods. I think like old object-oriented languages like Smalltalk, also called messages, but I'm not exactly sure. But definitely this is kind of a message you send to the contract and get something in return. So the first one is actually a very simple one. It just says, okay, when someone asks for the total supply, I will just return the total supply, right? It's as simple as that. From self is the first argument. It's the method is on a certain struct, so the self is this struct this method is executed on. In our case, it's an instance of the smart contract, meaning that if you write a dot like this here, you will get to the struct that we declared earlier, one of its fields. Now you need the inc message macro above a message, and the function needs to be public in order for this to be like a well-formed method of a smart contract. Of course, you're again similar to the storage thing. Your contract can, of course, contain functions and methods that don't have the inc message macro, but then they won't be callable from the outside, from the contracts UI or with cargo contract or with the Polkadot.js API. And importantly, the contract needs to have at least one method marked with the message. So similar to the constructor, and it's again the contract macro that enforces it. Another thing that might be interesting, but you will learn this quickly if you try experimenting on your own. The self, the first argument, the actual contract instance, it needs to be marked as a reference in the method. You cannot do it the other way. That's the default. Now, the second method is actually quite interesting and very rusty in its spirit, let's say, because we want to get a balance from our mapping, a balance of a specific account. It's called the owner here. It's some account ID. Recall that we have a mapping from account ID into balance. Now, what we do is we call of course, we get to the balances, mapping. We try to get the entry stored under this given key. Again, we need to pass it as a reference. Now, what do we get back? We get back not the value, but a wrapped value. It's wrapped in something called a result. It's gonna be on in just a slide or two. But basically, this tells us, okay, it can either be a success box with something inside, or an error box with an error message inside. Now, that's exactly. This is exactly what I'm talking right now. I'm talking about the comment. What happens if something's not there? Exactly. So if something's not there, we will basically return the error box saying that there's going to be some error inside, something like key not found, entry not found. What we do here, we could handle that explicitly. So match. If we got the OK result with the value inside, return the value, or if we got the error, we return 0. But here we just do it in one handy method. We say unwrap or default. So if the result was a success, just return what was inside. In this case, for an actual owner in this table, this would be the actual balance, or return a default. And we recall what I said, that the good default for like numbers is 0. So if the owner was not in our balance sheet, we will return 0. And this actually plays really well with the whole transfer model we're gonna come up here next. Because, if someone's not on your platform, or if you have a bank and someone hasn't used your bank, you can, without loss of generality, say, their balance is 0, and every equation still works quite well. And we're going to exactly see how in a moment. Because what happens when we want to do a transfer in this model with the mapping with the balance sheet? We say, okay, Alice wants to transfer 100 PCs to Pete coins, not the actual PCs. Wants to transfer to Pete. Too many names. To Bob. So what the contract does is basically first it needs to check whether Alice has enough funds to actually do this transfer. If she does, it will subtract this amount from Alice's balances and will add the same amount to Bob's balances. And this is how the transfer is done. Now, actually, a thing to watch out for here, and the thing to watch out for is if we do it like this, so first decrease the balance of Alice and then increase the balance of Bob, you need to be sure that your language makes this atomic, because otherwise, if there's some explosion in between those two, you would get with like a wrong state. Basically, some tokens would disappear. But this is a side note, and Ink, if something happens, Ink will just revert the whole transaction. So it's not a problem here, but basically, you need to be aware of such issues. Now, this is the implementation of the transfer. And there's a few things I would like to focus on here. Most importantly, the error handling here, right? So, as I said, the first thing that we check is whether the from account, so the sender, has enough balance. If they don't, we return this error box. So this is the outside error with some error description inside. In this case, it would be insufficient balance. Now, also note this is the first bright green arrow. The other one is the thing that happens when everything went okay. We just return okay. On that later. But then we proceed to do what we described just on the previous slide with the pictures. So we go to the balances mapping, and first of all, in our example, the from account would be Alice, the to account would be Bob. So we know that into Alice's account, we need to decrease the value by the value we want transferred. So this is exactly what we want here. Now, we have two balance here. So this is Bob's balance in our example. We check what the balance actually is, and we add the value transferred to this to Bob's balance and insert it to the mapping. Now, about the question, what happens if this account was not even present in the contract yet? Well, this is good, because if the from account wants to transfer some value to the account that hasn't even used the contract yet, this is exactly what happens. The to balance will be 0. So into the balances mapping, we will insert a pair, the to account, Bob, and to balance plus the value transferred. And the to balance will be 0, so we will just insert the value transferred. Simple and beautiful. I love it. And then of course there's the event, not important for now. Also, this is a pattern that's quite common in Ink. So doing methods that take all of the arguments through reference, and then only exposing like a wrapper method that, it does some initial preparation, but then just simply delegates the call to another method, but with the references instead of passing by value. This has to do with how WASM optimizes calls with references. So it's in general good to prefer references in WASM development, in Ink development. Now, you might have noticed that inside of this, I didn't include line numbers today. With this return error and so on, we are using some struct with an error, and this is pretty much the canonical way to handle errors in Rust and in Ink. So what we do is we declare this enum. Enum is basically a type that can be one of the values here. So in that case, you can think of it as a sum type. So it can be any of these. Oh, it's actually kind of like a union in C, but perhaps a little bit better, typed a little bit better. Or if you know algebraic data types, this is very similar. So in our case, we say that the error can be one of, well, of course, insufficient balance, zero recipient address. So basically, if you want to transfer to some invalid account, can be also a custom error. And now, what we do with it, we don't return it directly. We say, okay, if we have a computation that might fail, let's create this type. Again, it's an enum, so it can be either the OK part or the error part. The capital letters are basically type parameters, so it can be any type you want. So the T will be a type of the value that's returned on success on the OK part, and E will be some error description or even, I don't want to say exception because this is purposefully avoiding exceptions because they are just a glorified goto, as we all know. So once we have this type, whenever we have a computation that might fail, we can either return the OK part, wrap the result in the OK constructor if everything went okay, and in the end return some error if there was an error. By the way, here we can also declare like an alias, because if, let's say that this has two parts, the error part and the OK part, if we are always using strings as the error part, we can simplify it and just write my error and only keep the OK type. This is just a convenience hack, it's not type checked. Yeah, so coming back to this example, you will notice that this method here returns the result. This is already the like aliased version. And if the balance is insufficient, it returns the error part with the insufficient balance error inside. And if everything is okay, it basically returns an empty okay. And now what's cool about this is that basically you can react to the errors in your logic, and this basically behaves exactly the same as any other flow of data in your program. This is in contrast to, for example, exceptions that can like cut through the whole execution flow and bubble up, and sometimes can be very hard to reason about. This is very expressive and actually good to reason about. Yeah, so once we have the transfers implemented, one of the last things I wanted to show you in terms of writing this PSP22 contract is the events. The events are not actually a part of like the on-chain logic. They are used by external software to basically gather some information about what's happening in your contract. And the way we declare them is, okay, there's this yet another struct. You should be quite used to them by now. You need to mark it with the inc event macro that again does some magic, and it has some fields. Each event will have these fields, and if you use the inc topic macro, it kind of works. It allows the external indexers to basically index this field. So similar to how databases can index a column to make it faster to search through. Now, in general, it's good to put those, but if you have a field that like has a very big difference in values, so like changes with every call, it makes no sense to index it, right? So we are skipping it for value, which is just a number. Now, yeah, the exercise here is, if you want to say in the comments, I encourage you to, but this event is emitted every time we do a transfer, right? So why are the from and to fields marked as optional? Like, in what cases is there a transfer that doesn't have a sender or a recipient? Yeah, maybe this is an interesting exercise to someone. Now, yeah, the way to emit the event is the following, using the env method. Now, this one thing I forgot to mention is that this option type that you see here, and one of its instantiations, sum option, is just as a result, except the like the bad part, the error part, doesn't contain any description, it's just empty. Beat pressure submissions, yes. Token generation event, like minting, and burning is the opposite of that. So with burning, there's a sender, there's no recipient, and with minting, there's a recipient, but there's no sender. Yeah. So so this is the way, like the, well, let's say, canonical way of emitting the events. You can go to some of our repos on Cardinal Cryptography and actually see a slightly more involved way of sending the events, because this can break when there's multiple contracts and so on. But yeah, this is outside of the scope of this presentation again. Now, an interesting concept is this payable macro. So because every contract actually has an account, it has a balance, so you can transfer some value to it. You can also transfer some value when calling the contract. And please note that there's two different types of value that we are talking about here, because there's the token we've just created, and then the value transferred is obviously, well, in our case it's Bitcoin, but the value we're talking about here, and the transferred balance and the pay in payable, this is about the native currency. So in terms of Aleph Zero, this would be A0 tokens, or T0 on testnet, and so on. Yeah, so like I put on the slide, it's useful if you want to take some fees or deposits or something like that. And of course, the contract can inspect how much was transferred. Yeah, so don't read too much into this slide. This just serves the purpose of showing you that you can, and you actually probably need to write unit tests for your smart contract. Now, we're gonna see that in a minute if I'm successful in sharing my screen, but Ink now supports two types of off-chain tests, because, well, the smart contracts execute on a specific blockchain, but we can simulate a lot of its behavior just by running some local tests. And this is actually our first step in making sure that the contract is actually okay, and it is robust and it doesn't break, right? So first we write the unit tests. Basically, you'll need a module in which you'll put methods with the ink test macro, and they will run on your local machine, which is actually cool because the feedback loop is much shorter than if you wanted to deploy to the testnet or to your local node. This is quite quick, and yeah, you can get quite far with this. Also, quite a new feature in Ink, starting with Ink 4. Ink now supports end-to-end tests. So actually, the idea is similar to unit tests, but the end-to-end tests allow you to test your contracts more comprehensively, to actually test all of the features, whereas the unit tests have some limitations. But yeah, in general, the takeaway here is that you absolutely need to test your contracts locally, then end-to-end tests, then tests on testnet. Any kind of testing you can do is good, because, well, maybe one caveat here is that basically smart contract code is usually quite simple. Simple meaning even if it's like a complicated financial instrument, it's usually just a few hundred lines maximum. So we might think, okay, this is simple code, this is short, this is not like a huge system. But the problem is, once something goes wrong, the damages can be huge. So yeah, we need to write this extra carefully. Now this is a bonus, and again with my poorly contrasted slides, but remember what we talked about with the result, returning the result type from computations. So now you might think, okay, this is all cool, but if I need to examine the result of each computation and then I have two pathways, then it's very quickly turns into like a very cumbersome tree of ifs or some weird methods. And to that I say, that would be true if we didn't have this very handy shortcut. So imagine that we have a method that, well, basically we have two methods that both return results and return results with different error types. This is quite important. If it's the same error type, it's very simple. So now we have two options. One of them is to use some methods like we've seen before, like for example the unwrap or default, which kind of don't require you to go into the tree of ifs. But the other method is basically this. So you might know actually this pattern from other languages, but we are saying more or less something like this. Okay, let's write this computation pretending that the methods don't fail, and if one of them fails at any point, we will basically fail the whole full outer method. And you might think, okay, but these two methods, so might fail one and might fail two, return two completely different error types. And to that, Rust is saying, okay, as long as you can provide me a conversion from like error 1 to error 3, that's the type of the foo method, and error 2 to error 3, which is, like again, the unclosing error type, you're good. You can just, use the question marks, write the code as if it was like pure code, so with no errors. And basically, if an error happens, it will fail the whole computation. This is actually, to me, like I'm a retired Haskell developer, and to me this idea seems very monadic, so it's quite cool. I think if you Google like Rust question mark pattern, you might be able to get more information about this, because this is just like a small teaser. So I won't get into the details of, for example, this implement from my error for my error 3. This is basically a conversion method that you will somehow implement. Now, deployment on the chain. And I think, so I have some screenshots, but I think we can do, and I'll try to do it. I think I'll need Adam's assistance in order to do it. I will actually
Here to help.
share my entire screen, but I think you need to allow me to share it. Oh yeah, okay.
This one or not this one?
Yeah. Okay.
Okay, perfect.
So I have prepared the token here, and if you want to see what I've ran, I basically ran cargo contract. Can you see my screen? Adam, I think you'll need to help me because I don't see the chat anymore.
Yeah.
Is it visible?
I think we can see it.
Oh, that's perfect. So I ran cargo contract new token 1, and now what I have here is this very basic structure with, as I mentioned, the lib.rs file and the cargo toml file. Cargo log got generated later when I run the build command, but if we inspect it, we'll see that there's a lot of stuff that got created for us with the tokens and everything. But this is the macros I talked about. This is the module, and it's named the same as as what we gave to cargo contract new. There's our storage struct. So this basically implements the very simple flipper contract. So it just has a 1 Boolean value in the storage, but still, you don't need to worry about the macros. You basically have got the whole structure here, so I can just add some, add some second value, and it's all gonna be good. Now, yeah, basically we have everything here, like simple methods, mutable, not mutable, some tests, some end-to-end tests. So we're actually, pretty advanced here in terms of like starting the work on smart contracts. So that's one thing. Another that we can take a look at is the cargo toml file, which is basically basic info about your contract and some dependencies. Obviously, the most important one is the ink dependency. If we, for example, want to use some library, we'll probably put it somewhere here. So yeah, so this is what was created for us. Sorry. And now I ran this. There's no changes now because I pre-built it, because it's sometimes can take a long time if it's the first time you've created the project, because it needs to download some libraries and then it can incrementally compile it. But we have this target directory, and if I go to the target directory, I have the ink directory then, and you may remember our contract file, and this is what we are going to upload to the contracts UI. So now what I do, I'm gonna go to the contract UI. Well, as you can see, I played a bit with the contract, but I'm gonna just add a new contract. So like upload new contract code. You can also add a contract that's already deployed by someone else, but we're gonna just upload a new one. I have some accounts, so I'm gonna use one like this. Let's call it test contract 123. This is just a name. Now I'm just gonna need to find the right, it's sorted like this. Yeah, target ink token 1 contract. Okay. What the system is doing now is basically verifying if the format is okay, if everything makes sense. It's the bundle contains the actual code, the WASM bytecode, but also the JSON metadata, which, for example, tell you about the methods that are inside, and it can display their doc strings. This is for you and the users of your contract to know how to interact with your contract. Yeah. So okay, everything is cool. Now we can call the constructor. So the previous step was basically uploading the code. This step is actually instantiating the contract. This is the flipper. So yeah, we can initialize it with the false value. So you do it all in like a very graphical fashion, and there is some estimations of how much is gonna is it gonna cost in terms of gas consumption and storage fees. There's some more advanced options that I for one don't use. Let's just go and deploy it, and now we can just upload and instantiate it. Of course, you'll need to sign the transaction with your. Oh, by the way, I'm using the Polkadot extension. Yeah. So now we have the contract deployed, and this is how we can interact with the contract. Now, yeah, we'll choose the color. Let's use the same one, and the first one is the get. Oh, there's a Boolean value inside. It returns false. Importantly, it can, for the getters, it can actually calculate this offline. So no like transaction is made. If we want to mutate the storage, it's actually marked with this small like database sign. We actually need to perform a transaction. Oh, and again, this is doing like a dry run here, so you know more or less what you're gonna be charged and if the call will be successful. We can do flip, sign again. Okay, that's cool. And now we flip the value, so if we now run get, it should be true. That's great. Oh, and you can also actually see what events were generated by the chain. Okay, so this is more or less what the deployment looks like. I'm just gonna stop presenting my screen. Can we go back to the slides, Adam? Awesome. Yeah.
There you
So I basically had this in night mode as well here, but I thought I am gonna do a live demo. Okay, so basically, as a set of closing remarks, I wanted to show you some of the cool, like, useful developer tools that you can use when developing with Ink. This one actually made by one of our ecosystem members and a good friend Dennis from Labs. It's called Inkathon, and this is basically a full stack boilerplate for a ink-based dApp. It gives you some front-end templates, it gives you some back-end, and it gives you some smart contracts. So I think this should be the fastest way to actually start your development. Not to say that you shouldn't be able to actually write a contract on your own. It's very good to actually be able to do that, but this is a very good starting point. A second mention would be OpenBrush. If you're familiar with OpenZeppelin, this is more or less a similar thing, except adapted for ink. It basically gives you, like, batteries included implementations of the most common token types. So PSP22, so like a fungible token, would be one. PSP34 would be the NFT. It's also there. And actually, the cool thing about how it is structured is that you basically need some few imports, and then you create your struct. And to be honest, most of the work is basically implementing this PSP22, well, or 34 interface for your contract. You need to also initialize the contract in the constructor, but it basically takes care of all the boilerplate. But what's cool is the way it is structured in terms of extending your contract. So here, what we were writing is this basically very bare bones PSP22 implementation, but you probably also want metadata. So with OpenBrush, you just import the metadata and implement this straight for your contract. You might want it to be able to mint tokens, to burn tokens, also extensions. You might want to do, and probably should, do access control. So there's also an extension for that, and there's more. So yeah, it's structured in a really nice way. There's an interesting tool called Soul to Ink that, well, it's kind of experimental, but it should be able to transpile Solidity code to ink. So you can give it a try. For simple contracts, it might actually give interesting results. There's also a similar tool called Solang that you might want to check out. Yeah, so that would be it in terms of my slide and presentation. The QR code here is actually an assignment of sorts, so kind of like a smart contract scavenger hunt, if you may. Yeah, you can give that a try. It should be fun, and definitely will teach you a lot about interacting with smart contracts. And yeah, there's one Bitcoin for you. So that would be it for me. Thank you.
Perfect. Thank you, Pete, for this presentation, for the like live presentation as well of the code.
Yeah, it was stressful.
I already scanned the QR code, so it's a challenge on a GitHub repository. So be sure to check this out. Maybe too much for me, but I'm gonna at least read the description, what is expected to do in there, and what's the output. Thank you all for coming, for being here with us this whole time. It's almost 1.5 hours, so it was not this short, but hope you find it very interesting. Hope you learn something. Of course, as I said before, the recording gonna be available on our channel. If you have any questions, you can reach us out on any social media. I think LinkedIn is best, let's say. And yeah, thank you once again.
Yeah.
Have a
Thanks
good
everyone
evening.
for tuning in, and thank you for the questions here in the comments and for the kind words. Appreciate every one of you.
Yeah, stay tuned for next meetings or next webinars we gonna prepare of similar topics. And of course, yeah, warm congrats to our friends from Aleph Zero. Is, I don't know if one of the biggest Polish project, I think.
I think we're up there at the top
Yeah.
of Polish projects.
So yeah, and you also have an office in Krakow city, I know, right?
Yes, we do. Like the main development office. Yeah.
Great. I'm, yeah, it's close to me because I live in Krakow right now, so maybe I can give a go to your office, see how's the work going on in there.
Definitely, you should catch us. I'm sorry, but Cryptstar is writing comments are disabled. I'm not sure. I even
No,
have
I
the.
think comments are on.
Okay, I'm just a guest here. I don't have any access.
Yeah, no, the comments are not blocked. At least not on our YouTube stream. And maybe it's, yeah. If you there's I see the next comments coming. Yeah, people want the Bitcoin.
Yeah.
Not a financial advice, but it's not gonna skyrocket, so don't buy it.
Oh, Blackbot is asking a question. I just need a second to parse it.
Okay.
Well, so I don't think this will be our focus anytime soon. Yeah, we are always open for like ecosystem projects, building any use cases. We are if the team is right, I think we can even collaborate on like a more low level integration. But that said, our focus is of course keeping our chain running smoothly as is, but the liminal privacy framework. So we have only as much resources, so we're trying to pick our battles here. I hope that answers the question. But definitely a good idea, and let's keep the conversation flowing. We definitely have the contact on Discord, so thank you. Space Catch. Yes, we are. Yes, we are. There will be some launch pads. I'm not sure if I'm actually allowed to disclose more, but definitely on our radar. And yeah.
Great. Do we have more questions?
I'm
glad you keep that
until
until the end. Good questions. Okay, I don't see any new questions coming. So if that's all,
Oh, there's actually one last question. Bitcoin when? You know,
ah,
all jokes aside, I don't think it would be actually good for like a core team member to launch meme coins on our own chain. So probably we'll keep it at the joke level and not actual implementation. Oh,
yeah, we got one more question
Going to the moon.
from Blackbot.
Oh dear.
could you elaborate? Actually, what do you mean? When common? Soon. It's definitely the work is going on common. Oh, sharding. So I myself have no knowledge of any ongoing developments in that area, but then again, right now I'm more focused on the ecosystem side of things, and if the maybe someone is thinking about it, I just don't know about it. When Dex, it's being developed, right? So expect some information. Well, I would say soon. I don't feel like confident giving you any estimations on common, but definitely it's being developed. Common meaning common good parachain. No, this is about common our decks and some additional ecosystem around that private decks.
Yeah, just keep following Aleph Zero Twitter. They posted like a lot of information what they're working on, and the soon might be different from the point of view. So for one, from the point of view of the company, soon might be a year. For the people who are watching us, soon might be a month. So there is a big difference. Just follow the social media. They post a lot of interesting stuff on Twitter, on LinkedIn. So it's really interesting if you're into that
Sure.
kind of topics.
Okay, so the last question and probably my last answer. I play mostly jazz and folk and some electronic music.
Great. So now for real, thank you, Pete, for coming.
Thank you so much for having me.
Thank you
Thank you
guys
for being here, everyone.
yeah, of course, for being here. And have a good day, better evening, and see you soon. Ciao.
See you.
Alright guys, so that's pretty much it for the video today. We had a really good exercise here with the Aleph Zero team. Really cool. I don't think anybody is on my stream anymore. Everyone just dropped out. So, yep. Thank you guys for viewing. Have an excellent day. Again, take a look at this beautiful mug. Check it out. You guys can't. What the heck? Okay. There we go. There we go. Nope. There we go. Look at that. Look at that. So shiny. So beautiful. Alright guys, well, have a great day, and I'll catch you guys in the next video. Peace out.